The article, Pedestrians' Crossing Behaviors and Safety at Unmarked Roadways in China, modeled the time in seconds pedestrians wait at a median line at an unmarked road by the following PDF, where f of x is equal to 0.15 e to the negative 0.15 x minus 1, where x is greater than or equal to 1. So from 1 to infinity is where x exists. All right, so the expectation of a continuous random variable is always the integration over the sample space x times the PDF. So in this case, that is, the expectation of x is equal to the integration from 1 up to infinity of x times 0.15 e to the negative 0.15 x minus 1 dx. All right, so taking this integration is a little bit trickier than ones we've done before in the sense that we have to do integration by parts. So what this means is that we have a function where we want to integrate a u dv, which is equal to then uv minus the integration of v du, where in this case I'm going to define u to be equal to 0.15x, so that's this section, and I will say that dv is going to be this section, so e to the negative 0.15 x minus 1. All right, so du is then equal to 0.15 dx, and then to find v, we basically have to integrate dv, or take the antiderivative. So this is equal to negative 1 over 0.15 e to the negative 0.15 x minus 1. All right, so now we've kind of set up our v's, our u's, and we can then do the integration by parts, which is then equal to uv, which is 0.15 x times v, which is negative 1 over 0.15 e to the negative 0.15 x minus 1 minus the integration of v du. So v in this case is negative 1 over 0.15 e to the negative 0.15 x minus 1 times du, which is 0.15 dx. All right, so let's go ahead and clean this up a little bit. First of all, we can clean up these two 0.15s. They cancel each other out, and we get this first expression to be equal to negative x e to the negative 0.15 x minus 1 minus then the integration, and we're going to clean this up a little bit over here too, minus a negative, these cancel as well, e to the negative 0.15 x minus 1 dx. All right, so again, this goes from 1 to infinity. Let's go ahead and just leave our bounds of integration for just a moment and integrate this expression. So first, these guys get carried along, so negative x e to the negative 0.15 x minus 1. And if we integrate this expression, we get then minus negative 1 over a negative 0.15 e to the negative 0.15 x minus 1. And now we have to evaluate this expression from 1 to infinity. All right, so let's go ahead and just remove these two double negatives, so these become a positive value, and evaluate the expression at infinity and 1. So this is equal to negative infinity e to the negative 0.15 infinity minus 1 minus 1 over 0.15 e to the negative 0.15 infinity minus 1. And we're then subtracting off the expressions for 1, so that means we're actually going to add this, so plus x e to the negative 0. Not x, that would be 1, because we're putting in 1. So 1 e to the negative 0.15, 1 minus 1, plus 1 over 0.15 e to the negative 0.15, 1 minus 1. And we can quickly see that through L'Hopital's rule, we can find that this is actually going to just go to 0. Same thing over here, that e to the infinity will go to 0 as well. So basically we have 0 minus 0, which is 0, plus then over here, this expression will go to 0 right here. So e to the 0 power is just 1. So this was 1 times 1. So 1 is what that expression is equal to. And then same thing here is this will also be equal to 0. And so e to the 0 is 1. 1 times 1 over 0.15 is what we get. And then this expression is equal to 7.67. So the average or the expected value for this random variable. So the average time we expect the individuals to wait at the median line is 7.67 seconds. All right, so calculating the expectation is pretty involved, especially when we have to do integration by parts. I just wanted to show you one time on how you can easily calculate this. It just takes a little bit of organization when you're doing your calculations. All right, so the next thing we want to do is we want to calculate the standard deviation of x. So if we want to calculate the standard deviation of x, we need to then find the variance of x, because the standard deviation is the square root of the variance, which is equal to the square root of the expectation of x squared minus the expectation of x quantity squared. So, of course, we already know this value. This is equal to 7.67. So let's just set that aside for a second and calculate the expectation of x squared. Well, this is equal to then the integration from 1 to infinity of x squared times our PDF, which is 0.15x, no x there, 0.15 e to the negative 0.15 x minus 1 dx, and we can calculate this through integration by parts like we did the previous example. It just takes one more iteration of the by parts integration, and so we're just not going to do that in this video. It just takes a little bit too much time. So you can calculate it on your own and find that this is equal to 103.22. And so now we can simply just plug that into our formula up here. So again, the standard deviation is equal to the square root of the expectation of x squared, which is 103.22, minus the expectation of x squared, which is 7.67 squared, which is then equal to the square root of 44.4, which is equal to 6.66. All right, so then that is the standard deviation. So on average, the time that people wait at the median line deviates from the mean 6.66 times, or 6.66 seconds. All right, so now we want to find the median of x and the 10th percentile of x. So to calculate these values, I recommend that we first calculate the CDF, the cumulative density function. So f of x is equal to the integration from our lower bound up to the placeholder x of our PDF 0.15 e to the negative 0.15 of t minus 1. So t is just a placeholder right now. And then if we integrate this, we of course get negative e to the negative 0.15 t minus 1 from 1 up to x. And now if we plug in x, we get negative e to the negative 0.15 x minus 1 minus a negative e to the negative 0.15 1 minus 1, which we know that this is just 0 again, and so e to the 0 is 1, and we're actually subtracting a negative, so this is just adding a 1. So get rid of this. So if we make this a little prettier, we can say that our cumulative density function is 1 minus e to the negative 0.15 x minus 1. Now, I calculated this first because now when we want to calculate the percentiles, we can just easily plug in values. So basically, by definition, the median, so f of x median, is equal to 0.5. So what this means is that if we plug in 1 minus e to the negative 0.15, if we plug in our median value to this, it should be equal to 0.5 because that value cuts off 50% of the data. So 50% of the area falls below our median. So we can just now solve for this expression. All right, so what that means is that e to the negative 0.15 x median minus 1 is equal to 0.5. So I've just gotten rid of the 1. And this then is equal to the natural log of 0.5 over the negative 0.15 plus 1. So our median is equal to this expression, which is approximately 5.62. So what this means is you could plug in 5.62, integrate from 1 up to 5.62, and you should get 0.5. All right, so now if we want to find the 10th percentile, so x of 0.10, we've kind of already laid down the groundwork. This is by definition equal to 0.10. So this implies that 1 minus e to the negative 0.15 x 0.10 minus 1 should be equal to 0.10. All right, so again, if we manipulate this, we get e to the negative 0.15 x to the 0.10 minus 1 is equal to then 0.90. If we take the natural log, divide by negative 0.15 and add the 1, we get then natural log of 0.90 divided by negative 0.15 plus 1, which is equal to 1.70. And this is the 10th percentile. That means that 10% of values will be less than 1.70 seconds.